Yeah, I'm working for Solaris Bank, go engineer there. We'll start my little consulting company mid of next month, so I'm open for projects. And let's talk about event sourcing and CQRS. So first of all, what really is event sourcing? So it really means you have events instead of entities as application state. So, and the main difference is that these are events like from the real world, i.e., you open an account and only provide the data that is necessary for that. And so you have an open account event that only contains that data instead of a create account event that would contain all the data that eventually makes up an account. And further events are history. So you record them after the fact and you shouldn't rewrite them. Instead, you create new events that change the state, and then you can later see what has been going on. And events can be fetched very efficiently. So either since the beginning of time or everything newer than X. And so the upsides are you have an event store, which is really a combination of a database and a queue. And this is always consistent. This isn't trivial to do if you would implement this separately by yourself. And everything is replayable, so you can always start again since the beginning of time. And this gives you a lot of traceability. And especially for error analysis, this is really good. And in the usual distributed systems that we have nowadays, this can be really, really great. And now let's talk about CQRS. So CQRS is command query request segregation. And so the lower row shows the command part, where you have in the lower two rectangles like one service that is handling commands, i.e. the write requests, and writes them to the event store. And in the top row, we have the query requests that are handled by the query handler, and there's a query service. And this can just fetch the data ready to be served and then hands it out quickly to the client. And the update between the event store and the specialized query store is asynchronous, and thus the whole system is eventually consistent. But typically the difference is like 200, 300 milliseconds. So it's not such a big deal usually. Sometimes it can be seconds or even a bit more when you do really complicated things, but this is in practice relatively rare. And so let's take a look what upsides this gives us. So you have a, first of all, clear specification how to cut microservices. Yeah, there's not just vague, oh, find natural boundaries or whatever. You have clearly have a write, put it there. You have a read, put it somewhere else. And further on, it helps you separate things further too. It helps quite a lot there. And new query stores can be invented later, right? You still have all the events since beginning of time. You can replay them anytime to a new store. And then you can have completely new queries that nobody thought of when the system was started. And this is fine. This is really powerful. So I assume very much when you look at a product on Amazon, there you have all these little lines with suggestions. And over time, there came more and more lines with different kinds of suggestions. And I think these are all CQRS based. So nobody will complain if the last click they did somewhere on Amazon isn't inside any of these suggestions reflected. You can't prove it anyway. And so the asynchronous and eventual consistent thing doesn't matter at all there. And the computation can be very long and time consuming, like machine learning in the background or something. And so this is a quite ideal case for this. And so they can invent new lines later and remove them if they don't work out well enough and add something else and so on. This gives quite a lot of flexibility there. And it gives you more or less endless scalability, right? You can have highly specialized stores and you can scale the read services independently of the write services. And so this is really scalable there. And even writes can be quite fast. You can write asynchronously without full validation and later add some validation and still reject it on another state and send an email back or whatever to the client. Or when the next time he logs on, then they can see, okay, something was wrong there, I have to update it or something. Gives a lot of freedom there too. And it's quite perfect for companies like Amazon or Google or so. And yeah, so I was really, really hyped when I saw this and understood this all the first time. And this was the biggest upside for me, right? I was really happy. I was fully in love with this and thought, wow, this is so great. I have to do this now. I have to conquer the world. This is the great new thing. And I want to totally live that life. And yeah, I will work like for Google or something. And this is so great and clearly shows, of course, I'm good enough for them, right? And yeah, and we'll write one of these famous blog posts too that I was reading. And I will be invited to big conferences and become quite like a star, right? This is so cool. And yeah, my next employer, most likely Facebook or something, will of course value my experience and be very happy about it. And even my current company, if it really has to scale so much, I saved them, right? It's so great. It's only upsides. And in the end, I will be like the next Steve Jobs, right? Maybe not exactly, but at least drinking beer with Martin Fowler or something. And well, in reality, um, it's a big ego trip. Sorry. Didn't work out like that. Instead, my company never really did CQRS. We had management a couple of times almost convinced to do it, but it didn't really happen. And yeah, consequently, I never wrote this cool blog post and yeah, didn't get invited to conferences, and future employers sensed my big ego too. So didn't look so good. And time changed, and eventually I found a company that used event sourcing with Kafka, but without CQRS. But it was a fully event-driven architecture, and Kafka is really fancy, modern technology, really cool, and event sourcing and everything. I thought, oh, this is what not to like about it. This is like 3/4 of CQRS they had in place too, and thought this will be really, really great. So let's take a look. But after a while, I found some downsides too. So there is not that much tooling available, especially in the Go world. I think .NET and Java have more tooling for event sourcing and so on, but in Go world, there is not much going on, and especially if you have a store like Kafka without delete and update operations, this can be really bad. We will see this later. And for Kafka, we have a lack of hosting, right? We found a hosting company and they said, oh yeah, we do Kafka and performance is quite good too. And yeah, it turned out performance was like only 5 times worse than what we had with our own hosting, and that they don't do permanent hosting. They only allow Kafka to be used as a queue, but not as a permanent database store. So this didn't look that great either. And technical changes like simple typos or any small glitch that happened to get into production and you received a couple of events with that, you couldn't change it. There was no way around. Something happened. It was an event. You change history later. So that was our bad, and we had to live with this. And I felt quite bound by this. This wasn't the thing I was dreaming of. This made my heart feel a bit heavy. And unfortunately, this wasn't all. Pivoting can be even more difficult, of course. You don't have only small technical changes to events. Now you need real business changes to events. And this is even more difficult. And cutting events in a different way is totally impossible. We had the problem that we didn't take the advice that I said at the start, that we did use events from the real world. Instead, we had these entity-based events like create an entity event, update an entity event, and delete an entity event. And yeah, this wasn't that great, and doing it better was more or less impossible. Would have been a rewrite of the whole system. And yeah, that might have done the binding even more, and we couldn't move much in any way. And we're quite sad about this already. But unfortunately, then came GDPR along. And with this General Data Protection Regulation, there came some really bad stuff our way. I read out this for you now. It says, more serious infringements go against the very principles of the right to privacy and the right to be forgotten that are at the heart of the GDPR. And you can imagine an event store where nothing can be updated or deleted is completely against the right to be forgotten, of course. So this is just as much against it as you can go, possibly, I think. And yeah, the fines aren't fine. They are more like up to 20 million euros or 4% of the firm's worldwide annual revenue from the preceding financial year, whichever amount is higher. So if your annual worldwide revenue is more than 500 millions, and you always dwarf your revenue from last year because you're growing so much, then you can survive this maybe. But no, our company wasn't like that, unfortunately. And so we had really hard fights with this. And this was really, really bad. And there wasn't much going on with additional features or something. This locked us up quite completely. Right? We had really bad time there. And yeah, to be honest, it's all really just one downside, and it can be mitigated with enough tooling, but you would have to invest like 5 to 10 million euros to do that upfront, and then you could use this setup in a really great way. But we weren't Google, we didn't have the financial background, and so yeah, this didn't happen really. And we really wished for a simple monolith. This would have been, we dreamed of it sometimes and thought how much simpler it all would have been if we would have just could have back our old stinky monolith instead. Yeah, and the main thing to learn is please never use an event store that doesn't let you update or delete events. This is in the long run, even if it's a bad thing to do every time, but in the long run, you can't get around it. So let's take another look what happened after that. I found a new company and they did event sourcing, but with Postgres. So Postgres, you can update and you can delete. And they use CQRS too. So there would be upsides to this. And I thought, okay, this is something that might make sense. So I give it another try. And so happily started there. And well, after a while, you know, still there are little downsides. Still, it's good to have a lot of tooling and it's not that easy to get. And yeah. And you don't have only this one command and one query service like in this nice graphic, right? This is a schema, but this is only for like one use case. But in reality, you have many use cases. So they have this like 20 times or 50 times or something. And even the writes to the query store, you often don't want to do via the same service that is doing the query processing, because the queries you want to scale independently. So you have additional services for that. They are often called projector services. And if all those services aren't really independent of each other, you even need reactor services that just read events and emit new events. And yeah, so all in all, you have quite a lot of services and complexity, and it's easily more than 100. And often it's like 3 to 10 times more than would be reasonable in a down-to-earth way. And so let's take a look, what could you do instead? So I think it's really good to understand CQRS, right? And it's even more important to prevent anti-CQRS. So you really don't want a read to take forever because it needs to join like 30 tables or to go to 10 different stores and cobble things together from there or something like that. This is really good. It's good to know this pattern, but maybe not so good to use it like everywhere. And you can use many status values. And so, for example, when you accept a write request, you can first store the data and say, okay, give it a status received. And you can do asynchronous validation there too, and set it to validated or accepted later. And you can even subscribe to database changes with Postgres. And you can use extra tables, right? Like write first to a table that is specially built for this request, and later asynchronously write to the real tables that are used by all the queries. And then you have kind of a mini CQRS that you can invent later if really necessary. And of course, you can use history tables for traceability and debugging, or even legal purposes or something like this. Can be often used, be filled by triggers, so you don't have to care about it much in the programming language. And so that's all quite nice, and it gives us quite some upsides. It's all as simple as it is really reasonable, I think. And you have a quite nice upgrade path towards something like CQRS, and you get at least like 90% of the scalability too. With sharding and so on, you can go quite a long way. And CQRS doesn't get its scalability by magic, or by this little acronym, or just by splitting the reads and the writes. You can better scale the read services, of course, but usually that's not the bottleneck, but the read store, the database behind it is. And so it really comes down that you can use simpler and more scalable stores for the queries. And there you can do something very special, but you can do this the other way if necessary too. If you can prove that this will save the company, you can do this in a more traditional setup as well. And so you get at least 90% of the scalability, I think. And this can go a really long way. And of course, it's much easier to onboard new developers, especially more junior developers or so. And managers will still value your technical know-how, right? If something goes wrong, they still want to have your know-how. So you don't need this over-engineering to prove how clever you are or something. Life always gives you opportunities to show how good you are. So you don't need to create this artificially. And yeah, instead, management might let you work on open source, right? If you have a much simpler product and deliver good value quickly, and you have some additional time that you can spend on some open source project that can be really highly technical and cool. And there you can really show off and write cool blog posts or whatever, right? And yeah, this biggest upside is developer happiness, I think, right? So in the end, you work like most companies would really like to work. And this shows you are, of course, good enough for them. And it's like 99% of all companies. And that's just like a few, it's like 10 companies or maybe 50 worldwide that really need CQRS. And you can still write cool blog posts, and yeah, in the end, you can even speak at conferences. And yeah, your next employer, yeah, even if it is Google, they will value your experience and that you choose simplicity over cleverness. And yeah, and if your company really has to scale, you know an adequate way. And you can do this in steps, and this is not a huge upfront cost where you hope that it will pay off one day. And yeah, even your open source know-how, if you spend your time on some project that your company is using anyway, like Prometheus or Kubernetes or something, this can be really handy if something shows up there. You need to do a bug report. You know the ideal way how to do this. You know who to approach, and maybe even can fix the problem yourself. And that's really cool too. And yeah, if you help others go such a way, you can even get promoted because you're good with dealing with people too. And so that's it, really. Thank you. And yeah, if you are interested in more pragmatic software design, architecture, and hands-on coding in Go, then let's stay in touch.
Thank you very much, Ole. That was a great talk. And we have some questions for you. So, which are your favorite libraries for event sourcing / CQRS in Go?
And my favorite library?
Yeah.
Oh, we never used any special library anywhere. I don't know there exists special library, especially in the Go world. We found much tooling there. So sorry, I don't have library that I like.
Your own libraries.
I mean, that we use libraries like for the database drivers or whatever, right? Or accessing the stores. And for Kafka, I think there are 2 libraries out there in the open source world, and one is the official one, better maintained, but might not be ideal for this use case. And the other one is not so well maintained. And yeah, so I don't have a real favorite there. I would say, yeah, maybe better don't go that way at all.
Cool. And then next question, have you ever considered a technique such as crypto hashing as a solution for GDPR?
Sorry, Natalie, you are so...
I'm sorry. Have you considered using a
plug
technique such as crypto trashing as a solution for GDPR?
So now I understand you. Can you ask again, please?
Have you ever considered using a technique such as crypto trashing as a solution for GDPR?
Crypto crashing?
Crypto trashing, so spelled same as trash.
Yeah. I have a vague idea what this is. No, we didn't. I mean, you want the events in Kafka to be easy to read, to get the speed that you want to have. And you just can't get them out of Kafka. That is the problem. You would have to rewrite everything, at least everything you need, to a new Kafka log. And then the hard thing is the changeover from one to the other. And if you have to be online all the time, you can't do this easily. And this is the really hard thing that we didn't manage. Otherwise, you can just, of course, go over Kafka, ignore all the old events that you don't want to have anymore, and then write only the new interesting events to the new Kafka instance, and then move on from there. But if you don't have a weekend or something off for that, this is a real problem.
Right. Yeah, I think we have no more questions from the crowd, but I have a question. Would you tell us a little bit about this cool hobby of yours that you have in the background?
Yeah, I've been speed skating for some time. So 97 it started. Funny side story, it was my first race ever has been in my old hometown in Flensburg. And we did some rounds around there. And whenever you go up from the harbor level to the sides, then you have to climb up quite a steep hill. And we had to do this like 6 times. And this was quite a hard race, but it was my first and was still fun.
How many races would you say you've done over the time?
I calculated again, I think it's around 50. So it was like 4 intense years where I did a lot, and in the summer it was sometimes like every weekend. So on.
Well, from speed skating, it's clear why you like the speed of Go.
Yeah.